All right. So our next talk is by Nicole White, and it's how to build a Python web application with Flask and Neo4j. So please welcome Nicole.
Thank you, thank you. Welcome to building a Python web application using Flask and Neo4j. Let's just get started. So I wanted to tell you a little bit about me first. I'm Nicole, and I first attended LSU in Louisiana, got a degree in economics and math. And then I attended UT Austin in Texas, got a degree in statistics. And now I'm working for Neo4j as a data scientist in San Francisco, California. And I code mostly in R and Python, but today I'll be talking about Python. So the context of this talk is Flask and Neo4j, obviously. Most of you probably know Flask is a popular Python web framework. It's like an alternative to Django, which we heard about earlier. And a lot of you might not know about Neo4j, but it is a graph database, a fully ACID graph database. And if you don't know what a graph database is, hopefully that will become apparent as we get through this presentation. So Flask. Flask has a really nice Hello World tutorial online. You build a microblog application called Flasker. Has anyone done the Flasker tutorial? Awesome. So I think it's pretty good getting you set up with the basics. This is what the end result looks like. You have some text fields to fill in, and some data gets written to a database, and then the data is displayed to you. So it's a really good getting started with Flask. And the Flasker tutorial uses SQLite, obviously. It's super easy to get started with that. It ships with it, and it's a very straightforward way to get started with Flask. But I'm going to, instead of using SQLite, we are going to use Neo4j instead on the back end. And we're doing this because we're going to extend Flasker, the microblogging application, to extend it with social features. So we're going to add a bit more features to the application. We're going to allow users to tag their posts with different tags like categories. And then we're also going to allow users to like other users' posts. So it's going to be a more social app. And we're also going to use that data to make social recommendations to the user that's logged in, right? And I'm doing this because I think there's a big lack of like Hello World level tutorials out there that use a NoSQL database. And I think doing this will fill that gap and make them seem more accessible to people who have not used a NoSQL database as their backend for a project. So to familiarize ourselves with Neo4j, we're going to take a short journey from SQL to Neo4j. And I'm doing this because I think it's easy to understand a graph database when you take something you already know, like SQL, and translate it into a graph model. So in our example application, we have three main entities. We have users, posts, and tags. And in SQL world, we would probably end up modeling it like this, right? We would have a users table that would have its primary key, obviously. It would have a username and password field and whatever else you need to store about your user. And then we'll have a post table. And then it would have a user ID field with a foreign key back to the user's primary key. And then, of course, all of the fields about the posts. And then we'll have a tags table for all the unique tags that a user might tag their post with. And then because posts can be tagged by multiple tags, you have to have this intermediary table. People call it different things, junction table, join table. And then convention is to name it like post tags, and then it will only have the two fields, right? It'll have the post ID field, the tag ID field, and that'll have foreign keys back to the respective table. So this is a very classic way to model this kind of data in, for example, SQLite. Then, if you wanted to answer a really simple question, like give me all of the posts, the username of the user who posted the post, and then a comma-separated list of tag names, you'd have to write something like this. And we'd have to join all of these tables together via all the foreign keys. So join the users table on the post table on the post tags table, and the post tags table on the tags table to get all of the information. and then you have to write something like this. And I think even at this point, with this very contrived example and a very simple model, we've already had to write way too many lines of SQL code. I'm kind of biased, so I think any amount of SQL is too much. So let's look at how you would model this in Neo4j. So in Neo4j, you don't have tables or foreign keys anymore. You have nodes and relationships. And instead of fields in tables, you have properties on these nodes or relationships, right? So the user node will have a username and password property. The post node will have a text, date, whatever else, properties. The tag will have a name property. And then to model that a user published a post, you simply create a relationship from the user node to the post node saying the user published this post. There's no intermediary foreign key or anything. And then to model that a tag has tagged a post, similarly, you create another relationship, but you call it something else, call it tagged, call it whatever you want, really. So we're saying the tag tagged this post. And recall that a post can be tagged by multiple tags. So to do that in Neo4j, there's just no intermediary table to control or to keep track of this many-to-many or one-to-many relationship. You just simply create another tagged relationship to that same post node saying this tag tags that post too. So no more joint table. You just have nodes pointing to each other. And then this is the query you would write to get the same information in Neo4j's query language, Cypher. The only foreign thing about the Cypher query language, at least if you're used to SQL, is this match clause at the top. And you pretty much just essentially draw out the graph pattern that you're asking for. So here, we're starting at a user node. We're traversing the published relationship to a post node, and we're also traversing the tagged relationship from any tag nodes that tag that post, right? And then we're returning the username, the text, and the collection of tag names. So already we have a more intuitive data model, and we're writing a lot less lines of query code. So we're getting up to production faster when you don't have to spend hours troubleshooting a SQL query and writing SQL queries. And we also have not had to do the step where you do create table with all these fields. You know, there's like a specific step in the Flask tutorial where you have to create the database table. Neo4j, you don't have to tell it what you're doing before you do it. So the Python part of this that we need to make this happen is PyNeo. You can install it with pip. And the syntax is pretty straightforward. This is the Neo4j Python driver, and it's going to allow you to talk to Neo4j from Python. So the syntax here is from PyNeo. You want to import the graph, node, and relationship classes. Initialize the graph object first. That's going to do all your reading and writing to the database. And then the syntax here is to create nodes. The first argument is the type of node. So remember we had user nodes, post node, tag nodes. This will create a user type node where the property username is Nicole. And then we're going to create another node, a post type node, where the text property is hello PyCon. And then we can create a relationship between those two nodes by using the relationship function, right? So the first argument to the relationship function is the start node, which is going to be the user. And then the second argument is the relationship type. We're going to call it published. And then the third argument is the end node, so the post. So we're saying user published this post, and we pass that entire thing to graph.create to actually write it to the database. So that is essentially all you need really to get this up and running. All right, so application features. If you have a laptop on you, I would love if you participated in the live demo of this Flasker tutorial that I have up and running in production on Heroku. I need at least one person to do it with me, otherwise I'll be very lonely in my graph and my social recommendations will be empty and sad. So if you could, navigate to neo4j-flask-blog.herokuapp.com, and hopefully it is up and running. And we're going to walk through all the application features step by step. I'm going to show what it looks like, how your data was added to Neo4j, what it looks like in Neo4j, and then we're going to go through the code that made it happen. So the first thing we're going to do is, can I get confirmation from at least one person that it works? OK, great. So the first thing I'm going to do is register a user. So I'm pretty much going to follow the same steps that you would have gone through in the Flask tutorial using the SQLite database, except we're using Neo4j instead. So I've already registered, so I'm going to go log in. But you can click the register button to make a new account. And you should get something like this. Should have something that looks just like the output from the Flask tutorial. And let's go look at what this data looks like in Neo4j. Oh, great. We have participants. OK, so that just created a bunch of nodes in the database. No relationships yet, so nothing terribly exciting. But all of these nodes now have a username and password property. If you can see down here, that's showing you all the key value pairs on that node. So here we have loc, and then we have an encrypted version of their, or a hashed version of their password. Right? So pretty straightforward there. So what happened? In views, so in Flask, convention is all of your views go in views.py, so all of your pages, and then all of your like classes, functions, all of that logic goes in models.py. So we'll first go over what it looks like in views.py, and then we'll look at the class, the user class, and the methods in models.py. So in views.py, the register page looks like this. This is pretty much stolen from the Flask tutorial, modified slightly to use Neo4j. But essentially, if you sent a GET request, you were just given the template. Otherwise, we got your username and password out of that form, and we do a few basic checks to make sure they're long enough. And then we call this, we create a user object initialized with the username, and then we attempt to register you with the register method. So I'll show that in the next slide, what the user class looks like. And then we start a session variable that allows you to track users through multiple requests throughout the website. And then we say you were logged in, and then we send you to the home page. But we're going to go over the user class next. So the user class looks like this. Like I said, it's initialized with the username. And then we have this find method that's going to use that PyNeo graph object. And we're going to use the find one method. It's going to find one user where the username is equal to that username. So that's the syntax there. The first argument is the node type. Second is key. Third is value. And that's going to return a PyNeo node object in Python. And then we have a register method that you pass a password. And then it's saying, if that user is not found in the database, so we don't have a user by that username yet, then go ahead and register them. Otherwise, return false, because that user already exists and you have to pick a new username. But what we do here is the same syntax I showed earlier, where we create a new node by passing the node type and then an arbitrary amount of key value pairs that we want to be on that node. So we gave it a username and then an encrypted version of the password. And then we pass that to graph.create, and that actually writes it to the database. All right, let's add a post. I think most of you probably have. And the tags are comma separated. So that would hopefully add a post to the database. Now let's go look at how this looks in the Neo4js. So here, let's click on one of these. Zoom in a little bit. So here we see a legend. The green nodes are posts, the red nodes are tags, and the blue nodes are users. So here we see people are already jumping ahead. They're liking posts, but that's OK. So there's a post. Title is so cool, published by Ziad. Digu liked it. Digu posted a test post, apparently. And this post is tagged by awesome. Let me find a post that would tagged by 2. There we go. So this one is tagged by 2 tags. So, and that's the model we discussed earlier. So let's go look at, actually, let me go through the, it's kind of hard to see with this resolution, but the post nodes have several properties on them. So, in views.py, the add post endpoint looks like this. It only accepts a post request. So When you clicked share, it sent a post request to this endpoint, and we got the title tags and text out of the request Flask. Flask gives you a request variable that lets you parse out the data that's sent with the request very easily. So we got the title tags and text out of that. We do some basic checks to make sure they're not empty strings and give you an appropriate error message. And then finally, if it all checks out, we initialize a new user object, and we send it the username attribute off the session variable, which I explained last time was the way to track a user across requests in Flask. So that's the user that's logged in making the post, and then we're going to call the add post method for that user, and we're going to pass title tags and text to that add post method. And then we send you back to the home page. So then in models.py, again, still in the user class, we have the add post method here. So again, title tags and text are sent to this. First, we find the user in the database with that find method that was shown last time. So user is a PyNeo node object at this point with that user. Then we're going to create the post. Again, the same syntax here, node. Then we're going to just pass the node type. It's going to be a post type of node. And then those are all the properties that we want to put on the post node. We're generating a unique ID with UUID. And then we're putting in the title and the text as properties. And then I have some functions elsewhere that get the current timestamp and date and put that as properties on the post. And then, as we've already seen, we create a relationship between the two by passing them to relationships. So user published post, and then we create the relationship by passing it to graph.create. Then for the tags, it was just sent to us as a string. So we lowercased all of it, split it on commas, and then we stripped out white space. So that's just a list of cleaned up tags there. And then we're going to iterate through the set of that. And we're going to use graph.merge1. It's kind of like find one, but it's find or create. So if the tag already exists, it will just return it to you. If it doesn't, it will create it. So if I've created a post that used tagged Python first, and then you do the same thing, you don't want to create a new tag node with name Python. You just want to retrieve the one that already exists when I did it first. So the syntax here is the same as find one. It's the node type and then the key value that you want to match on. And then, so for each of those tags, we create the relationship that the tag tagged the post and pass it to graph.create. All right, I think a lot of you have already liked posts, but you can click on the like buttons. You can like your own post if you want. And that will just send a request to one of the endpoints that we'll go through in a second. But the result there is pretty straightforward. I don't even need to do a new query here. It simply creates a relationship from a user to a post saying that they liked that post. So pretty straightforward here. We get the username off the session variable again. If no one's logged in, abort. If someone is logged in, again, we initialize a user object with the username, and then we call the like post method, passing it the post ID out of the URL. So if you view the URL of the like, you should see /like post / the UUID of the post. And then we say you like the post, and then we sent you back to where you came from. So the like post method, pretty straightforward, nothing terribly new here. We find the user with self.find. We find the post, it already exists, of course, for you to like a post. So we find it with graph.find1. We want a post where the ID is equal to the post ID. And then we're going to create the relationship user liked post, except here we're using create unique, graph.create unique instead of create, because we don't want to allow a user to like a post more than once. So if you click like over and over, it will only create the liked relationship once in the graph, if that's your desired behavior. So create unique is kind of like a merge for relationships. If you do want to allow users to like a post more than once, then you can certainly just use graph.create. Next slide. Okay, profile pages. So the actual like social recommendation part of this. So hopefully I have some recommendations. Okay, good. So when you visit your own profile, it's going to recommend similar users to you, up to 3. So here I have a few recommendations saying Catapix also blogs about Python and Neo4j, right? So, and then if I visit someone else's profile, unfortunately Catapix has not liked any of my posts, but it's going to show you so-and-so has liked X of your posts and also blogs about these tags. So 2 things happen there in the profile page. You could either, if you visit your own profile, you're going to get recommendations for similar users. If you visit someone else's profile, it's going to show you what you have in common with that user. So what does the profile page view look like? The endpoint is /profile/username. So the function is going to take the username as an argument. So the first thing we're going to do is get that user's most recent posts. So when you visit a user's profile, it's going to show you only their 5 most recent posts. So we'll go over that function next, get users' recent posts. We're going to initialize 2 empty lists for later. We're going to get the username of the person viewing the page off the session variable again. And if someone is logged in, then initialize the user class again with the username. And then these next few parts is saying, if the viewer username is equal to the username of the profile, so if you're viewing your own profile, then call the getSimilarUsers method off of that viewer user object. Else, otherwise, you're visiting someone else's profile. And so we're going to call the getCommonalityOfUser method off of that user class, which we're going to show in a second, and pass it the other person's username. So in models.py, the first thing we do, like I said, is get a user's recent posts. So here is a Cypher query to do that. I don't know if you can see that. We're matching on a user that published a post and all the tags that tagged that post. We already saw that kind of earlier, where the username is equal to parameter username. It's kind of like the question mark in SQL for parameters. So we use curly braces for that. And then we're returning several properties off the post. And then finally, we collect all the tag names into one row, ordering by timestamp descending, limiting 5 to get the top 5. And then we get all of this as a sort of, it's essentially a list of dictionaries with graph.cypher.execute. The first argument is the query itself. And then the rest are filling in the parameters, if any. So we're saying the username is the username that we asked for. So that's going to get that user's 5 most recent posts. And that's how that is displayed to you on a user's profile page. And then visiting your own profile, recall we're going to recommend 3 similar users for you. So here we find 3 users who are most similar to the logged in user based on tags they've both blogged about. So here we're matching on you publishing a post that's tagged by some tag, and they, another user, publishing a post that's tagged by the same tag, where you are you and you are not them. We don't want to recommend yourself to you. And then we collect all the tag names, we count them, order by the count of that descending to get, we want the top 3 users based on you both blogging about the most tags together. And then we're returning their username and all of the tags that you've mutually blogged about, right? So that's how you get that little snippet on your profile page. This user also blogs about these tags. And then same syntax there with graph Cypher. Execute. And then when you visit another user's profile, this is what happens in the background to give you that little snippet about what you have in common with that user. So find how many of the logged in users' posts the other user has liked and which tags they've both blogged about. So we're gonna do that all in one query. So the first part, we're matching on just the 2 user nodes. We're matching on you and them by passing in the parameters for the usernames up there. And then we're gonna optionally match, which is kind of like a left join, because those relationships might not exist, but we still want to continue with the query. So we're matching on they liked a post that you published, and then we're getting all the similar tags, and that's the same as last time. So they published a post that was tagged by some tag, and you published a post that was tagged by the same tag. Right, so we're doing several things in this query. We're getting how many posts they liked and mutual tags you blogged about in just a few lines here. So we're counting how many posts they've liked, and we're getting all the tag names again. and then same syntax here. So that's how you get that little snippet that's like, so-and-so has liked this many posts of yours and also blogs about these mutual tags. All right, so conclusions are that NoSQL is not hard, and I think it's a good thing to consider for a project if SQL won't do the job, especially if you have a very highly connected data set or domain, and you want to be able to easily get up and running into production without having to worry about create tables, alter tables, doing all of that refactoring with NoSQL. Mostly across the board, it's schemaless. You don't have to bother with all of that stuff in development. So that is all I have for you today. Questions?
What about ORMs for Neo4j?
No.
No.
No. You kind of, I kind of made it myself, right, with the user class. But no, not. I think there might be some tools out there. You might have to Google it. Nothing that I've personally used and can vouch for.
Yeah, what about the error messages? I saw a race condition in the create user there, if not find, and then what would happen if all of us at the same time would enter the same username and register? How would it crash?
The same exact second.
Yeah, exactly. How is it helpful? Are you happy with how Neo4j?
Well, that was my own error message, right? I typed that out.
No. I mean, so you seem to be happy with Neo4j when it's working. But what if when Neo4j is not working, or some you have a bug in your code? Is it helpful to find it? Or will you just crash with a Java stack trace and you have no idea what went wrong?
I mean, the Neo4j error messages are pretty good. I mean, I run Neo4j in production for a few professional. At Neo4j, we use Neo4j in production. In terms of writing to the same node at the same time, we don't really have that problem because we use a load balancer. We have a master-slave setup, and that's all taken care of outside of, I don't really deal with that. But I mean, it's fully ACID, fully transactional. The transaction will get rolled back, and it'll tell you. So you can write, we have exceptions. There's if the transaction failed for whatever reason, we have different ways to handle different exceptions, and we try again if it's that simple. Otherwise, we have several different things to handle different exceptions. But yeah, PyNeo will expose all those exceptions in a very straightforward way, and they're easy to catch and deal with.
I have a question about benchmarking against SQL and stuff like that. So if you grow the database, how's the queries compared to SQL or anything?
So our classic marketing spiel our engineers did a test with MySQL versus Neo4j it had 100-ish million people in it, and it just had friendships between them, and we did the friends of friends query, and in Neo4j it's 100 times faster. Of course, that's not going to be true for every single domain. It's gonna depend. The answer is it depends, unfortunately. But my main thing with Neo4j and speed is the speed of just getting things done. I spend so much less time writing queries and thinking about modeling with Neo4j because it just seems more straightforward to me. And also collaboration among coworkers is just so much easier with Neo4j because I can read my coworkers' queries. Whereas back when I worked in consulting with SQL land, someone sent me a query, I had no idea what it was doing, typically. So if you want to know about speed, I could probably put you in touch with someone who would have better answer than I do.
Yeah, here, great presentation.
Thank you.
So I had also the same question about performance, because I worked previously with RDS data stores, and they were known to be slower than MySQL, but maybe that is, since they also graph, but maybe that is something different. But how about using Elasticsearch for the same Then you don't have to write any queries.
I've never used Elasticsearch. Isn't that a full text? Isn't that a text search type thing? That's not a graph, is it?
No, it's not a graph. It could be used as JSON store.
Oh, I can't really vouch for. I can't really compare the two because it's not a graph database, and I don't really know how I'd use it in place of a graph database. I don't have any experience using Elasticsearch in place of a graph database. I don't know how you would. But in terms of comparing their performance, I can't speak to that.
So I have a short question here about schemas.
Where are you?
Here.
Oh.
I mean, in SQL, upgrading the schema of a database is a big pain point. How do you do that in a graph database?
So I mentioned this earlier, how in SQL you have to do the create table, alter table all the time, right? And then in Neo4j you can just start adding data. But that's also, it's a blessing and a curse. I think it's a feature. Some people don't like it because you lose that strictness, right? You don't have anything that says only this type of relationship can exist between these two nodes, or only this type of node can be attached to this kind of node or something like that. You don't have that strictness. But in terms of changing your schema, you can just do it. You don't have to bring it down. You don't have to really tell it anything. So like, for example, like we started with an empty database just today, and we started adding the user nodes and the post nodes, and I never had to tell it, okay, now I'm going to create a liked relationship, right? We just did it, and it was added. So really, you don't have to do anything to change your model. If you want to change existing data, then you do a refactor, but you can do it live. You can actually, like in our trainings, we just write a Cypher query that does it in batches. So like if we wanted to change the liked to likes or something, we want to change the name of the relationship, we would match on them in batches of like 5,000 or something, rename it and whatever. You know, that's how you typically do refactorings in Neo4j.
Yeah, thank you for the awesome talk. And maybe you have some examples of domains that might use the graph databases with a great success, besides, of course, the social networking.
I think my favorite is the whole, like Walmart is a customer and they use Neo4j to do recommendations to users on their website for products that they might want to buy. That's one of my favorites. Also Shuttle, eBay. Logistics, Neo4j is really good at logistics. So the eBay one-day shipping is all through, at least that part of their business is through Neo4j. So yeah, not just social, logistics, retail recommendations, really anything. You can check out the website. Yeah.
We don't have any time for more questions, so thank you, Nicole.
Thank you.